lights are done. Cabinet lights, coffee lights around the perimeter. We are looking at 22 watts. But the AC is done. And obviously, you've seen the outside. Well, welcome back to part 6 here of the cargo trailer camper conversion series. At least in part 6 here, we're going to go over the electrical. Now, just to get something out of the way, I'm not a certified electrician. Definitely not telling you this is what you should do. I'm just showing you what I did. So install your own electrical at your own risk, just to get that out of the way. I just know enough to get my own self in trouble, so take this with a grain of salt. But if you haven't missed the other 5 parts of the series, at least in part 1.
We went over the reasoning and why I'm doing cargo trailer conversion. Part 2, we went over the rear wall construction and the screen door construction. In part 3, we went over the hydraulic lift bed and the kitchen construction. Part 4 is somewhat of a teaser of the plumbing, just testing it out, make sure it works. Just a quick overview of that before I do the final install. Part 5, we went over the rest of the framing, the wall liner and ceiling liner, and the insulation on the ceiling.
Part 6 here, this is how I did my electrical. Not saying it's correct, but for some reason you got to say this just to get it out of the way. Let's get this going. Now I have links for these items in the description box below the video, but I did get this off Amazon. This is the 30 amp shore power hookup. If I do obviously have the electrical hookup, I'm going to use an electrical hookup rather than using my solar generator or power bank. But just to splice in a quick picture of how I hooked this up to the 10-3 stranded wire, it was pretty simple. Matter of fact, I'm just using a vinyl J block here. I custom cut a piece of, I believe it was 3/4 plywood, and I used a specific hole saw to make that hole. And check out the advertisement of this on Amazon. They'll give you the actual hole size that you need. I just can't remember that off the top of my head. If I have the picture, I'll splice that in. But it was pretty simple to get this hooked up to the 10-3 stranded rubber wire. So let's head inside. So you can see your 10-3 stranded wire coming off your shore power hookup. Now this is a rubber sheathed 10-3 wire. It's not solid wire, it's stranded. I know some people say it's fine to use solid, and I just happen to use stranded. As a matter of fact, in most contemporary or new trailers nowadays, or campers, they actually use a combination of both stranded and solid. But at least for my main electrical runs, I decided to use stranded. Now, you can see I got a board here to make sure that all of this is fastened down securely. And this is coming out of that shore power hookup. On my main electrical runs, I got some flexible conduit pipe that I snaked the actual cable into before I fastened this all down with these clamps. And I'll splice in pictures of that right now, just give you an idea of what that looks like. But I think it's definitely well worth it to make sure that this wiring is completely protected, especially you're throwing in, you know, totes, maybe some, you know, grills that might have sharp edges to make sure it doesn't cut that wiring. But if I have the hookup, I'm going to use the hookup. And this is for 30 amps. You can get a special adapter that will adapt this from 30 to 15 if you're not aware of it. But this, at least for me, I use 10-3 stranded wire, and that goes all the way to the front of the camper. And you can see I ran a special electrical trough here. This trough serves 2 purposes: to protect the wiring, and also automatically spaces out the refrigerator that I'm eventually going to put in here, so it flushes out perfectly with the front of the base cabinet here. So this wire here goes behind the cabinet and then goes up the wall and then comes back around behind this door. And this is the special TV door that I created. So this is made out of 2x4s, recesses in the TV itself, and also acts as a door for the storage behind it and the electrical. And you can see that main 10-3 strand of wire coming through here. And I got this box from Menards. I like the Square D products myself, and I'll splice in a picture of what this looks like with this cover off. But this is coming in with the possibility of 30 total amps, and is connecting up with these two total 15 amp breakers here. So now that I got you up to this point, this 15 amp breaker comes off in its own wire and goes to this outlet. This one goes off in its own wire to this outlet. So I got two total circuits. Now, why did I do this? You can see nothing's actually hooked up to this right now, but if I had the 30 amp shore power hookup and it's applying power from the outlet outside, this cable is actually the charging cable for my Bluetti power station. Now, this has pass-through. What does that mean? If I have the power 30 amp and it's hooked up to an outside outlet, that power is going to come through here. It's going to my breaker box here, and it's applying power to both of these circuits, and this is the actual charging cable to the Bluetti power station. So that power is coming in, it's going back out, it's going down this cable, and it's charging my Bluetti power station. So just to show you right here, it's plugged into the charging port and it's going to charge us. Now, I don't have any power hooked up, but if I did, you would see an input of power charging this power station. And this has what's called pass-through. If it has power, it's going to pass that power through. It's actually not going to use the batteries inside. It's just going to pass the power through. So it's charging, and then it's outputting the AC, and it's outputting the DC. So these two cables, and the DC and the AC, come back out, and this cable here, right here coming out, is going to this 15 amp. This has a 15 amp circuit breaker, plus it's GFCI rated surge protector. And that cable that comes out of the Bluetti obviously powers this. And if I had this hooked up, you'd see this would be lit up. And then that power comes out of the surge protector and goes to my two circuit runs. Now, these cables here coming out of this GFCI 15 amp breaker, surge protector, are actual super heavy duty rubber sheath extension cords, where I cut one end off and I left the male plug not cut off, so I could plug this in to this surge protector. Like I said, this has a 15 amp breaker in it, and also it's GFCI rated. Now, I have two total circuit runs in my camper. One goes to the kitchen area, which is here, and I also have another outlet here, which I'll splice in a picture. There's an outlet back here where once I put in the refrigerator, I can run the cord for the refrigerator through this hole and plug it into this outlet. And also this outlet supplies power to this outlet, which is kind of a hybrid outlet. It's used for the kitchen, and it's also used for the bedroom area. The other cable here goes clear to the back of the camper, to this AC unit and the back outlet. So you can see that one cable goes all the way back up through the wall and goes to this outlet, and is dedicated to that outlet for one reason: the AC unit. It's going to draw some amperage, not a lot, but you know, we might plug some other items in here and that should be more than enough. And it's 12 gauge wire, stranded. So all those two main runs are stranded, other than that stranded, the other first circuit that goes to this outlet, solid Romex wire through MC cable up to this one. So I'm using a combination of both stranded and solid wires for this circuit run. And I'll splice in some pictures of this hooked up to a fan, and also this hooked up to a TV, but it works out great. If it has the power, it's going to charge this and pass it through. But say like I get a power outage, it will within a millisecond switch over to the power out of this power station for not only the AC but the DC, which is really, really cool. And if I simply don't have any shore power hookup, this will obviously supply the power. So this will power not only the AC, but also the DC. Now, at least for the Bluetti EB3A and all these other power stations, they come in different sizes. This is probably the smallest one that Bluetti makes, and this is a 268 watt hour. And usually these are a little overrated. They're usually about 85 to 90% efficient, so it probably actually does about 250 watt hours. But heck, some of these power stations, you can get clear up to 3,000 watts. Obviously, the more watt hours it can do, the bigger it's gonna be. And this is the smallest one that they make. Now, for pure example's sake, you know, if it's 268 watt hours, you know, efficiently, you could probably do 250 watt hours. Right now, on all these LED lights that I'm running, all those lights, all the lights underneath here, and even these lights underneath, it's using up 21 watts. Well, to figure out how long this is going to last, which this is actually pretty spectacular, 21 watts for all this lighting on DC. Right now at 87%, I'm getting over 9 hours of use time on that. And what you can do is if all these lights takes up 21 watts and you're getting roughly 250 watt hours, you just take 21 watts and divide it by 250, and that's how many hours. You can see that this is at 87%. It's not 100% right now. But once I hook up my DC water pump to this, obviously the more products I have hooked up to this, the least amount of time this is going to last. Now, right now, this is the DC run. This is the heaviest duty 12 gauge DC carport adapter that I could get off of Amazon. You actually see it has a fuse here on the side, and that power comes out of this DC cable and comes to my DC fuse box. Now, you can see I cut off the ends of that 12 gauge wire, and this up here where the fuses are, that's the positive. Down here are your negative hookups. So all your black wires are getting hooked up to the negative terminals here. All the positive cables are getting hooked up to the positive terminals here with your separate fuses. So so this is DC, this is AC. So if you're not familiar with this, this is the AC coming out. That goes to the AC circuit breaker, which is GFCI rated. It has a 15 amp breaker, and then comes out with its 2 AC runs. And then obviously the DC carport adapter is powering this fuse box, and that's simply how it works. Now, another reason why I did this is I want to keep this small and removable. And typically when you're outside camping, it is raining out here, so you might hear some of this rain hitting the roof. But usually when you're camping, especially with trees up above, your area might be completely shaded. And if you have permanent solar panels attached to your camper, those solar panels might not get any sun, but say like the corner of your campsite has sun. I can actually, once this dies, I can actually remove all these cords, take this whole unit outside along with my solar panel where there is sun, and hook that up, charge it up. And at least with the 100 watt solar panel I have, and I've tested this out, from dead, it will completely charge this up in roughly 4 hours, which is pretty spectacular. I actually plan on buying another one of these because these are very affordable. You can usually get them off eBay for roughly $200 or Amazon for roughly $200, $210. That's pretty inexpensive for what it does. It has the input for the solar. It has DC output and AC output. It has pass-through. It has uninterruptible power supply. So say like the AC power kicks off, and this is passing that AC power through, but you lose AC power. This will switch over to its own power in under a second, milliseconds, and you won't even notice that power loss, which is pretty spectacular for only $200. And this also has an app, so you can see how much power is coming into it, how much power is going out of it, how much time you have left. You can see it all from your phone while you're outside next to the campfire, which is pretty spectacular. But being that this has pass-through, I shouldn't really have to change anything. Like I said, you know, this is, if I have the power, it's getting charged up and it's passing that power through, and it's a flow. You know, for some reason, if I wanted to, I guess, if I wanted to, I could actually unplug this surge protector that has a 15 amp breaker, and it's also GFCI rated. I could actually unplug this out of the power bank and plug it directly into one of my circuits here. I guess I would lose my DC power. And that's why I plan on buying 2 of these. I actually have one now, but I'm going to buy another one. So if one dies, I can take it outside to get charged and hook up the other one, especially when these are only $210 a piece. It's a whole lot of bang for your buck. Now, obviously, they make different sizes on these power stations. This is only 268 watt hours. You can get these clear up to, you know, 1,000, 2,000, even 3,000 watts. Obviously, the bigger watt hours it is, the more batteries it has, the bigger it's going to be, the more it's going to weigh. So you got to keep that in the back of your mind. But this will go up to 600 watts of AC power, and it will surge up to, I think it's 1,200 off the top of my head, but each power station that you can recharge with solar power is obviously going to be different. So you're going to have to do a little bit of research, but at least show you the method to my madness of how this is working. But you know, right now, with all the lights at full bore around the perimeter, and let me shut this, you know, all the way around the perimeter here, underneath, also the lights underneath here, and even the light inside. These little puck lights, which I have a link in the description box below, take less than 2 watts, which is phenomenal. It's DC 12 volt power. It's using next to no wattage, and it will last a long time, even for this little power bank. At 85%, this is even 100% charged. It is 9.2 hours on 85%. And you can see it's using 21 watts roughly. And if I say, like, it's at night, we're watching the TV, we're chilling, and we got this lower down. Say, like, these are dimmed down a little bit. And I got these dimmer switches off Amazon. I got a link in the description box below. But if I have this dimmed down and I got these lights turned off, I am only using 5 watts and 28 hours left to go, even on this dinky little $200 power station from Blue Eddy, and that's pretty spectacular. That's why I think this is going to fulfill our needs for us. It is raining outside, so you might hear some of these raindrops, but everything was about electrical runs. I can actually pop this board off and access all that wiring. I'll splice in a picture of what this looks like. I just have a 1x4 here underneath, and I cut, I believe it was 1 1/4 inch holes with a hole saw for these puck lights. I started, I think it was with a 2 3/8, but it was too big. 2 1/4 was perfect for these puck lights. And I can make sure I use screws on this board so I can pop this off and access not only the DC wiring for this puck lighting, but the trailer lighting wiring. And even for the back, I can pop that board off to access that wiring. But I think that's really important, is you got to think down the road, make sure you can access all this wiring. If something gets a short in it or you have to replace some lighting, it's really important. Now, at least for my utility lights here, I just got a really inexpensive metal box here, and they actually sell these plates here at Menards. I actually drilled my own 2 1/4 inch hole into this plastic plate and used this puck lighting. I want to stick with this puck lighting because they use less than 2 watts, and that's really important to keep the wattage down so I don't kill my power source. But you can see I used all marine grade 12 gauge wiring, and it's kind of a pain in the butt to figure out how to cut this and strip it. Actually, what I did is I took a utility knife and I just scored it on each side and bent it, and and then I use a special pliers that kind of pulls the wiring apart to get this stripped. And once you figure it out, it's pretty easy. But I got thermal connectors here for this hooks up to my DC power fuse box. And this also comes with a plate. I'll have a link in the description box below for this also. But once you understand the method to the madness, it is pretty simple. And like I said, you're getting a lot of bang for your buck, especially for only roughly $200, $210 for one of these power stations. Now right now I have just the DC inverter powering that DC power to the DC fuse box, powering all these lights. Now if I want, I can turn on the AC inverter, which is right here. So I just click that on, you can see it now. See it says AC and DC. So now this is outputting power to my surge protector, and that power is now coming out to those two different outlets. And just to prove that this will work, I'm now powering this fan. So obviously, if you want to power a lot of things like your refrigerator, an AC unit, and a fan, this is probably not going to be enough. You're going to have to get something a lot bigger, something that can pump out a lot more watt hours, not 268 watt hours. You might need something more like 2,000 watt hours. And that's just a decision you're going to have to make. But at least with this fan turned on with AC power out of this AC outlet, with all the DC lights on at the same time, so both DC and AC run at the same time, you can see with 83% left power, we got 3.4 hours left. You know, if I had this TV hooked up right now, which I don't, but if I did, it's roughly about 40 watts. That would increase this to 100 watts, which obviously decrease the amount of time that is left on this power bank. So like I said, you want more power, you want more time, you have to just get a bigger power bank. Now, I'm in Wisconsin. The snow just melted. It's 35 degrees out. I'm sure the condenser is not going to kick in on this AC unit to truly test it out, but just at least show some of you guys. With all these lights on the DC run, pumping out 21 total watts. I do have the AC inverter on. I can plug in this fan. And then let's turn on this AC unit. So I got this on, let's see here, energy saver. I don't know if I can get this condenser to kick in or not. Let me see if I can get this condenser to kick in or not. I doubt it's going to, it being so cold outside. Let's see here. I don't think it's going to happen. I wish I could test this out for you guys, but it's just 35 degrees out. The thermostat in here is just not going to kick in the condenser to truly test this out. But I'll put this on high, at least on the fan. And this fan's running on AC. All the DC lights running at the same time. You can see I'm pulling 122 watts. Now, if it was 85 degrees out and I could get this condenser to kick in on the AC unit, this would definitely start pushing the capabilities of what this could do. And at least for us, you know, we need that just to get lights. We need it to power the DC sump pump for the sink. We need it to power the TV while we're chilling out at night. And we're only probably going to use the AC unit if we have shore power hookup, and that's about it. And it's really snowing outside here. It's no joke, a little above freezing here, Wisconsin, in late April. It's really important to make sure you ground out that breaker box to the trailer frame itself. And I'll place some pictures here. I used 10 gauge stranded wire that had a green sheathing on it, and I had that running down and screwed into the trailer frame itself. And to make sure that your AC runs run properly and make sure they're grounded properly, I can't stress that enough. It's really important. Well, I hope you learned something from this way I hooked up my cargo trailer camper conversions, especially with the Blue Eddy EB3A power station that, no joke, runs about $200 to $210. And check out the description box below. I have a link for all these products. And if you feel like you learned something from this, scratch my back and I'll continue to scratch your back with this amazing content by only subscribe, like, and share. And I will see you guys in the next part of the series, which is going to be the final part most likely. And that's going to be on the final installation of the plumbing. I'll see you next time.